and then a third number if you can read my mind. If not, just tell me what shapes you were drawing in that class. On Friday section. Can you say a little abstract?
So if you just multiply the value from the x and y axis and apply them to the graph.
Great. So good, you got it. So Lily and Kaylee, I penalize you because you're sitting next to the people talking. Hopefully this is not so bad. So when I get this 800 here, where does this 800 come from? What two numbers are being multiplied to get that 800? And you can pass.
You're multiplying the quantity 20 by the price.
Okay, so we're multiplying this 20 and this 40. Okay. At what quantity, as same group, at what quantity is the revenue 800 for this dot? What is the quantity related by this 800? 20. Good. So I'm just getting you back in the swing of things by looking at reading graphs. Okay. And so what we're doing is we're drawing different rectangles, as Kathleen said, exactly, the x and y axis, and we're multiplying them. The y is price, the x is quantity. When I multiply the two, I get everyone together that's following?
Revenue.
Okay, good, which is what we're graphing. The other key graph that we have is this one around elastic, unit elastic, and inelastic. On the Friday section, they taught you that neat math trick. Can you nod if you have any recollection of Friday and neat math trick? Okay? So if I, as a business, I want to make money, let me back up. Let me make fun of Yale for a second, because that gets weird. So someone from Yale will say elasticity is all about, there's revenue, there's price, quantity, it all goes together. But you can get lost within all these things. So what I need you to think is when you're trying to make a lot of money, you're thinking about where you want to price. You don't just say, I price wherever my dad tells me to, right? You try to figure out with experiments how the price relates to your revenue. And so you want to think, if I raise the price, a lot of times we think about raising the price. If we raise the price, do we want the quantity to drop very much if we want to make a lot of money? No. We want to raise the price and have very little quantity drop. So in that case, we are actually I'll just throw it again here so I don't have to go back and forth. Elastic, unit elastic, and inelastic. So if I do a what if, I'm in frame, everything's good today. What if I raise the price? What is the thing that I want in the business? You know, if I want to have a lot of revenue. I'll just blank this. I'll blank it for a second so you don't stare at that. What if I raise the price? The business, I want quantity. I know quantity is going to drop, but I want it to drop a little, very little, right? If I raise the price of a hotel, but I don't lose many rooms sold, that's really good as a thing for the business. So what I want here, remember that hokey thing with the rubber bands and the thing? I'm not going to take it out. So I apply a force and I look at the adjustment. Is this a lot of adjustment or a little adjustment? A little. So this would be inelastic. So in the inelastic region, now it's going to take time to warm up. Okay, in the inelastic region, when I raise the price, okay, the quantity goes down, but it goes down by a small amount percentage-wise. Percentage-wise. The slope here is always the same, but the percentage-wise is different. Here, the ratio of the percentages is going to be small. Going from $10 to $11 is 10% up, but going 50 to 49 is just 2% down. So when I make that movement from this point to this point a little to the left, I can look at how revenue changes, this point to this point, and revenue is going to go up. That's what I wanted you to get from the homework that you turned in. So if you didn't get that from the homework you turned in, you need to do the homework again. I'm not forcing you to do the homework again. Your desire to get a good grade on prelim 2, which is way far away still, is what should get you to pay attention to that. Okay? So in the inelastic case, when we're thinking about we want to raise revenue, when we raise price a little bit, we raise price, the quantity goes down a little, and this is all in percent terms. Okay? That's this inelastic region. Over here, when I raise the price, if I raise the price, the quantity goes down. Same slope, right? Up 1 over 1, up 1 over 1. But up here, in percentage terms, it's different. So over here, when I raise the price, I'm raising it 2%, or I'm raising something over 50. And here, I'm lowering it something over 10. My starting point is 10. So that's going to be a big quantity adjustment. I don't want that. So over here, as you can see, when you move to the left, now this is the confusing thing. Moving to the left is quantity down, means price up. But you're Cornell, hotel school. You should do this, be able to do this. And you're my student, so I get to ask you to do it, and you get to do it if you want a good grade. Moving to the left in quantity is always moving up in price. We see that from the graph up here. Left in quantity is up in price. So if that is something you've often missed, please write that down on your sheet, crib sheet, note sheet for the final, prelim exam. A lot of students forget these little details. They skip to go very fast. Okay? So in this case, raising price doesn't increase revenue. What does increase revenue if I start from this point? Well, we have only two choices, raising price or lowering price. With that, you're thinking of? Yeah, lowering price. So when we lower the price, out here, let me do some labeling. A is inelastic, A is inelastic, okay? If I look at this point B, which is elastic, then what if the price goes down? Okay. Then Q is going to go up a lot in percentage terms. Okay. Just keep it the percents right here in percentage terms. So this is what we want as a business. There are a lot of businesses that are charging too much. The way I know they're charging too much isn't I look at their price and say, oh, that's too much, I don't want to buy it. It goes from looking at the demand curve and thinking, oh, if we did an experiment and lowered the price a little bit, how much more quantity would come in? Right? So Max Cafe sells sushi for like $12, right? Something like that, $10, $12. If they dropped the price to $8, they would sell a lot of this. You know, and there's something in my mind of when you go to Terrace Cafe, you have to stand in that long line and students are busy, but Max Cafe, you just grab and go almost. So they need like an express sushi station at $8 for like 15 minutes where they just have a checkout just for that. If they did that, they probably would lower the price and get a lot more quantity. They would get more revenue from that because it is elastic. And in this case, the adjustment we want is the quantity going up. This is good review, good see the homework, the third. So you saw the class, you do the homework, you see this, hopefully things are done. It always takes 3 times to get things. 4 here from you.
So neither inelastic or elastic is bad, it's just an indication of which way you should move the price?
Correct.
Okay.
Inelastic and elastic is not good or bad. If you're thinking about raising prices, you want inelastic. But if you are in an elastic range, you can do things where you drop your prices and do well. Good insight. You put that in an aha, but not under your code name. Just make a code name. Anyone else? Okay. So determinants of price elasticity. So the number of substitutes matters. The more substitutes, the more elastic. I realize every year I need to change this because there's just too many words on here. So I'm going to blank this for a second, and I'm going to let you copy down. More substitutes means more elastic. More substitutes means more elastic. If anyone is looking for the page in their note, is there a section in there for this? 39. Okay. More substitutes, more elastic. Plain ticket, you can puzzle over this later, so I'm just going to say, suppose you have 10 different eateries here, and we're talking, in one place you have 10 different eateries, If the price is raised at just one of those eateries and you have 10 different alternatives, more substitutes, you're probably going to do a lot more switching to the other options. If I go to Martha Van Rensselaer, where human ecology is, and there's one cafe there, and there aren't very many substitutes, if you raise the price, there's not as much ability for me to leave. Okay? So depending on the number of substitutes, if you have more substitutes, it tends to be more elastic. These are not hard and fast rules, so you can find situations where there are a lot of substitutes, and it's inelastic, but these are just general principles. Now I'll just try to do this. If we think about a plane ticket out of Ithaca, and we're thinking about all of the planes, and everyone raises their price by $100, you don't have many substitutes. You have to drag to another airport. So that, I would think, is more inelastic because you don't have many substitutes. But if you just we're thinking about a plane ticket out of Ithaca on United, and I'll make it even more dramatic. For a specific time at 6 a.m., if they just raise that one price, you're going to be pretty elastic because you're going to think, oh, I could fly later, I could fly on a different airline, things like that. So that's what this is saying. This is a good example. It's just too many words to communicate effectively. So if you like stories, you should write down the story of one other restaurant in town versus 20 other restaurants in town. But I could ask this question on an exam, so you should be able to see the parallel between the substitutes.
Right, so more restaurants, more elastic?
More restaurants, more substitutes, more elastic. Sometimes this is visually helpful. So suppose these are all restaurants, 5 different restaurants, and this restaurant number 10, raises the price. So they all start out roughly at the same price, okay, same height, and then you raise the prices 1. Some people are going to switch, substitution to lower price goods. Okay. But if there's only one restaurant and you raise the price, people have to go to other places. So that's why the more restaurants means more elastic demand. And it would be demand for that one restaurant, not restaurants overall. Demand for the one restaurant that you're thinking of. As you'll notice, these examples, I'm changing the good, which is why this is confusing. In the first one, I'm thinking good is just plane tickets out of Ithaca. This one, I'm thinking plane tickets out of Ithaca on United specifically, so it's a different good. This one has more substitutes, this one has fewer substitutes. Okay. Next, general principle, necessities versus luxuries. Necessities are more inelastic, like insulin, a medication to live. Would you buy less insulin if the price doubled? I wouldn't if I had diabetes. Okay. Would you buy less Prada bags if the price of Prada bags doubled? Now, always there's a student who says, well, Prada is a luxury good and people like paying more for Prada because it makes it more exclusive and things like that. That's true. I think that's true. But the idea, I'm just using it as an example of necessities versus luxuries. If you go into this weird consumer psychology of positional goods, like if my shoes are shinier than your shoes or more rare than your shoes, then you'll buy more of them. Then all these rules of almost all the rules of economics get adjusted highly, okay? So in this case, it's thinking, what if you're buying Prada bags and it isn't, you just care about the Prada bags, not the exclusivity, not the other things, and the price of Prada bags doubles. You know, you're going to say, well, I don't need Prada bags as much as I need insulin. Okay, Prada bags. Okay, price. Do you have a question? Okay. If the price of a flight goes from 500 to 1,000, where will the percent change in quantity demanded be bigger? For business travelers or leisure travelers? Business travelers. So, how does that relate to the previous slide? I'm going to give. I want you to talk to the person next to you and see if you can agree on an answer, and then I'll call on. No, business travelers, not business plastic, it's business travelers.
Because business travelers don't even pay for their own tickets.
Yeah,
They
choice
don't
of how
pay.
much they're paying.
I know
Where
the
it's
general.
necessity
Yeah,
versus
whereas leisure travelers have a choice of whether or not they're gonna spend that.
Or you can think of it as a
Quantity.
This is an L, right? This is an L.
It's more like versus like an
I'm trying to
incentive.
Yeah.
use
Not for
necessity
losers.
versus
No one's a loser.
which one is more
There'd be a
necessary?
bigger right?
It's always did it. We're good at these questions.
Okay.
What are we doing?
I learned your names today, Jack and Joshua. So
Okay,
come on,
we're
you
doing
Jack
high
and
five.
Joshua.
I always go straight.
Hi, future generations.
Wait, you?
Let's all listen to Jack and Joshua. Where, using the idea, where is it
I
more
never thought
of a necessity?
Well, with business travelers, wouldn't it be more inelastic because they would have, like, because it's like a necessity for them to travel?
For their business, yeah. Let's say a sales manager needs to shake the hand of someone to convince them to close $1 million deal. They're not going to care about this 5 minutes. Leisure travelers who are thinking, maybe I'll fly there, maybe I'll drive there, maybe I'll staycation, maybe I'll do other things. They have a lot of other things that they could do. In essence, this is a necessity. And necessity also goes towards more substitutes. It's kind of related, right? The business traveler doesn't have other things they could do. Leisure travelers, if it's a luxury good or if it's not as necessary, a necessity, then they can switch to do other things. Good. I like that answer. Does anyone have any other insights or stories they want to share about this? Anyone thought it'd be the other way? I love it. It could be the other way. And I would always want you to tell me the story that makes you think it's the other way, and then I can tell you, yeah, if that's true, if that relates to where will the adjustment be bigger than this point. I don't see any takers. You can always put it in the AHA blog if you want. Notice I didn't write the word elasticity. I just wrote where is the percent change in quantity demanded going to be bigger. So that is cueing you towards this idea of elasticity. Elasticity is just the econ code word. Just like James Bond has money, penny, and Q and things like that. Econ has elasticity as our sort of some of our buzzwords. A few other determinants: percentage of one's budget spent on the good. If it's a smaller percent of one's budget, you're probably going to be less elastic, less adjustment. If it's a larger percentage of your budget, more elastic. The example I always like to give is pens. If the price of pens goes from 5 cents a pen to 10 cents a pen, I'm not really going to adjust very much. But the price of eating out doubles. You know, when it goes from $10 for sushi at Max to $20 in sushi at Max, I'm going to adjust more. It's a bigger part of my budget. If a plane flight, for holiday doubles, that I have to think about it more because there are more things I have to give up. You know, I have to. When the price of pens doubles, I don't have to adjust my budget very much, or so I can eat one less donut a year. I'll get my pen budget up. But if I do go on that trip, instead of $2,000 or $4,000, I have to think about cutting a lot of other things. So that's where this. So I answered the question: where is the percent coin demanded going to be bigger? Probably in eating out. In both cases, an increase of percent coin demanded will lead to a decrease in, an increase in the price will lead to a decrease, but elasticity asks about where will the percentage decrease be higher. Okay, so percentages, elasticity, percentage. So I'm very clear or very tired. But since you probably spend more on eating out, you'll adjust more your eating out budget, which is where the percent quantity demand is bigger. Okay. Time is also going to be an issue. So there's an idea of short-run price elasticity and long-run price elasticity. Justin?
Yeah, for that slide that we just did, I thought, I might have misheard, but I thought you said for the price of pens, we're not going to decrease.
Yeah, less adjustment. So price of pens is smaller percentage of my budget, less elastic, less adjustment. Did I say it backwards?
No, I'm just confused with that last line. In both cases, you would probably decrease.
Yes. You'd probably decrease. So where will there be more adjustment? In your eating out or your quantity of pens buying?
The eating out.
Eating out. You'll probably decrease in both of these cases if the price of pens goes up and the price of eating out goes up. But since you spend more on eating out, using this idea of percentage of one's budget spent on the good, I think I'll apply this rule. Eating out is a larger percentage of my budget. I'm gonna be more elastic, meaning more of an adjustment. You will adjust more your eating out budget.
Oh, so you're still buying fewer pens, it's just not as drastic as...
Not as drastic.
Okay.
That's the point of it. Thank you. So time, short run price elasticity versus long run price elasticity. People go into the restaurant, they raise the price, so I'll explain it with a story. People go to a restaurant, they raise the price by 20% on all items. That day, people will probably still eat there. They're not going to leave the restaurant because for 20%. You know, maybe you will if there's a restaurant right next door, but with the store, just think people aren't going to do it. And this is the short run. Short run, they're going to be more inelastic. People aren't going to leave. No one leaves perfectly inelastic. Okay? But over time, you here, I mean you as in the customers, adjust and might switch to another restaurant. If it's a permanent change, then you might see that people will adjust over time. And so the long run price elasticity is going to be higher than the short run price elasticity. So this is also, in a practical sense, there's so you need a takeaway to write down. The short run adjustment in quantity demanded understates the long run adjustment, or is always lower than the longer adjustment. Okay? So why this is important in cable TV companies are constantly raising their rates. People hate this, but they stick with cable TV. They're addicted to their shows. Lots of people complain, but very few people complain initially or cancel initially. If the company concludes that the elasticity of demand is low, then they're committing a Yale mistake, saying elasticity is elasticity. Okay? Over time, more people will defect. Defect here is cable cutting, Netflix, other things. They move to satellite TV, find other entertainment options. So in this case, the company would be making the mistake in understanding economics. They confuse the short-run elasticity with the long-run elasticity. More people will switch over time. So this is where the beauty of that rubber band with the weight on it and this physical analogy of I apply a force, how's the adjustment? If you think elasticity, it becomes something you have to memorize. But here, it's very easy to just think, oh, long-run adjustment or short-run adjustment? Do more people cancel overall after a year or overall after one day? I'm not talking about the daily cancellations. I'm talking about the cumulative cancellations. Will?
What do you define as short and long? Like, is it just depending on what, like time-wise?
It's just a principle.
Okay.
So there isn't a thing. If you're, I think it's related to the frequency of the business. So if it's McDonald's, short run might be 1 week, and long run might be 2 months. But if it's something that is more like the cable industry, would probably think 1-2 months is short run, and then they'd look at churn rates after a year.
Could they ever decide that even though more people are leaving, like the long run elasticity affects it, it's still worth it?
So they could still
Like
decide. So it might. This is just saying in what direction will the elasticity be higher. And this is saying that if you raise the price and wait 1 month versus raise the price and wait 1 year, the 1 year will have more adjustment. But if it's still inelastic, going back to this slide, if it's still this inelastic, the percent change down in quantity might still be small. They might still want to do it. So these aren't rules to say, oh, long run you should never do something, short run you should do it. That's not what it's saying. It's just saying that the comparison.
It'll be more.
Great question. Thank you, Will. Anyone else? I'll give you 10 seconds to think. I'll give you 10 seconds to think. Dude, thank you.
Can you say that if, like for example, like with the changing the price of Netflix or whatever, if there is no short-term adjustment, will there be a long-term adjustment? Like, can you say that, or is that
I think I think the story you're trying to tell is Netflix raised their price from $8.99 to $9.99. Is that what you're talking about?
I'm saying like after you adjust. Wait, hold on. Never mind.
Are we talking about Netflix or no?
No, I got it.
Okay, you got it. See, even when you don't ask the full question, you get it. So, okay, so practical, two business partners run a restaurant. Joe really wants to cut prices to gain business. Kevin is very much against it. They agree to try it out for a week. After a week, business only picks up a little. Kevin says this is proof that this will never work. Right? What is Kevin mistaken? Kevin's like, we tried it for a week, it didn't work. Well, a week is too short probably for menu changes. So mistaking short-run elasticity with long-run elasticity. A week is too short. Now, I think if you're doing menu planning, if you go to the establishment and you put two prices side by side, it might be instantaneous. Because if you have the Cobb salad for 12 and the steak for 20, and then you increase the Cobb salad price, there's not really the long-run adjustment would be more to other restaurants. But you might just thinking on the same menu when most people who go to a restaurant get one dish, so you can get a sense of that immediately. But in this case, they're talking about cutting prices to gain business from other companies. That's going to take time. Well,
if you cut prices and then it kind of by cutting prices, people expect that more often, that the price is going to be that? Is that more just psychological, not, these are assuming these people are just rational all the time, right?
So that's more psychological, and there is repeat customer thing, and we are not getting there. We're probably not going to we might talk about that a tiny bit in the whole course. Because that's psychology, and Jack and then Stephanie.
What about promotions though? Businesses doing promotions through city galleries?
So yeah, you could run a promotion for certain hours, and you want to see so if I run a blue plate special, 4 to 6 o'clock, special dinner, special items, think of it as 20% less. And so lowering that price then, I would expect more people to come in. There are a lot of details with that. So you're thinking about, do people shift from eating later to earlier?
But then it would return to, immediately it would be more elastic than in the long run. If it was
so I think what you're saying, and this is kind of helpful, we're thinking about, you're thinking over time, and you have the standard, so time is this axis, and this is sales. And I think you're saying when you introduce the promo, it'll increase, and it might take a little time to increase, but then it'll stay fixed. Is that the idea, or am I, okay, I want to get the question right. So this is the sales, and so this is a high price, and then everything here, this whole entire region has low price. So I think what you're thinking about is these adjustments. Over time, it doesn't adjust day to day. That's not the elasticity. Okay, that's why I hope is an aha for you. The elasticity is apply a force. You look at the different prices, and then you see how the changing quantity is. So what you need to do is compare something at here to here. That's the elasticity. Over here, this is just adjustment time. It's not an official word. You don't have to put it on your cheat sheet. But here, it takes some time for people to adjust, and eventually they'll reach some sort of steady state there.
You always compare it to the beginning.
Yeah, but if I compare 2 points here, are the prices any different here? No, so I wouldn't talk about elasticity. That's the key. No difference in price, no talking about elasticity. Stephanie, did you have a question?
Yes, I was going to ask if there are any scenarios in which the opposite would be true, where there's a larger change at the beginning and then it meters out.
Yeah, some people, if people get really angry about something and then they mellow out, then you'd expect that to be true. So when Netflix raised their prices, some people are like, oh, I'm going to quit Netflix immediately because they're angry, but then House of Cards Season 2 comes out, and then so stuff like that happens. But if they actually knew that, they wouldn't have quit. But the quitting is more symbolic. So here we're thinking econ is more about I'm buying things just for the consumption and value of those goods.
Mm-hmm. So there are no motions.
I'm sorry?
So it's, yeah, we're assuming that the people buying are completely rational, there's no.
Yeah, you'll probably find exceptions. If you think of exceptions, let me know, or we can talk about them. I can give you my opinion. You know, there's stuff about, if I use shoes as an example, please don't be like, well, one shoe you wouldn't. So on the homework, there's a left shoe, right shoe problem. That you have to kind of think about. But don't say, oh, well, an extra shoe doesn't matter because you need 2 shoes. Like, then it's a weird demand curve. We just say that's not economically important. We think about pairs of shoes. So, yeah. Togo?
I wasn't clear about what you were showing on the board about the question that was previously asked for Stefan.
Okay.
So what's the deal there? Like, what's the situation?
I'm going to ask someone else who was listening, because Togo was brave enough to ask the question. I want someone else to tell me what I was explaining, but not Jack, because he knows exactly what I'm saying. So what is this? What's the story? What's the difference between standard and prom? I should write promo so you can see it. Who's good with stories? I'm going to call on someone besides Laura. Lauren and Leah. What was happening here? You can say pass, and I'll kick it back to Stephanie. But give it your best.
At the standard price, there's like a constant quantity, but then when you added the promo, the quantity shot up.
Quantity shot up, and it
slowly
took some
over
time.
it like plummeted.
Thank you, Lauren. You have it exactly correct. I could not have done it better. And then the point there. So this would be the short run quantity adjustment. So this would be the short run quantity adjustment. What points would I compare for the long run quantity adjustment? I need 2 points. B to D is the long run.
Yeah, and then there's no adjustment anymore, so it stays.
Okay, stay the same. So if I want to look at, in the long run, what the percent change in quantity, I would look at this change in quantity. Yes? B and D? No, I think so. Not true. Very close, but not correct. So go.
I know that one, B, A. Isn't it from A and
A
H?
to D, okay. Because B to D is the same price. That's the adjustment over time. Something's not happening. So we want to think, where is the price different? A and D, the price is different. And I want to think about this delta Q as the long run adjustment. And A to B is the short run adjustment. Because this was where the prices were low. And then, so prices were prices were high, $10. Then you drop the price to $5 is the promo. You don't want to compare a $5 and another $5 time period. Like, if I had this go up a very tiny amount, I don't want to compare D and E.
So what would you call that increase?
B and D?
Yeah.
That is the additional adjustment between day 3 and day 30. No elasticity. Jack, do you remember what I said to you? So, no something, no elasticity?
No change.
No change in, help them out?
In price.
Change in price. Yeah. No change in price, no elasticity. We don't talk about elasticity when there's no change in price. Or change in something. This is just letting them slowly figure out the adjustment. Oh, I didn't know this restaurant was the low price. Yeah. Will?
Can it also happen instead of kind of plateauing up? Can it spike up and then come back down and plateau?
Yeah, that's the Netflix House of Cards thing that she was saying. Netflix House of Cards would be
spike
raise the
down.
price, spike down, and go up. So the other,
Like if a deal comes out.
you have a promo and people do it, but
And
then
then they
they're like,
kinda get-
it wasn't really worth it, and then they drop it. But that's a little weird because it's a subscription good. So
Okay, that makes sense the other way. If it drops down, then it still lowers, but not as much as.
So the key thing of this is the principles and ideas of thinking in a structured way. Ceteris paribus, we change one price, we think about how much the adjustment is. We think in percents, and we think about different scenarios where we think it will be higher and lower. to guard ourselves from making bad assumptions like Kevin here. Kevin, in this case, said, oh, after a week, business didn't pick up. Let's not try to make it. But you have to give some of these things. So other elasticities we have the same idea of apply a force, how big is the adjustment. The recipe is just we change either the denominator, the bottom fraction a little, and see what happens to the top fraction. But what we change on the bottom and what we look for at the top is going to change. We always are using percents. So with own price elasticity, we were using the percent change of the good we're thinking about, price, and the quantity demanded of the good we're thinking about. So on the same demand curve. When we do cross price elasticity, we do change the price of the other good and then look at the percent change in quantity demanded of the good we're thinking about. So maybe I'm thinking about peanut butter. I'm thinking about peanut butter and I apply a force. My force is going to be jelly. The price goes up a lot. So this is the force I'm looking at, and then I want to look at the percent change quantity demanded of peanut butter. So I look at the price of the other good, percent change in price of the other good, percent change of the price of the other good, and look at how it affects peanut butter. In this case, if jelly becomes super expensive, I'm going to expect the quantity demanded of peanut butter to go down because these are complements. Okay? What if instead I say, who has a good substitutes example? You have one?
For peanut butter and jelly, but almond butter instead of peanut butter?
Okay, great. Peanut butter and almond butter. Okay? If we raise the price of almond butter by a lot, and we're thinking we apply that force, do we think people are going to buy less peanut butter too? And we're holding the price of peanut butter constant, holding the all else constant. If almond butter, there's an almond shortage, California falls into the ocean because of the earthquake, no more almonds, people are going to buy more peanut butter because there's no almond butter. So here, we're going to have the percent change in quantity demanded go up. And this would be substitute. Because almonds and peanut butter substitute. Here is complements. And you can try to memorize it. People always mess it up. If you think about the story and just draw the diagram and say, oh, if I raise this a lot, and it's peanut butter and jelly, how do I do it? It'll be fun. And I just told you exactly what I did in this slide. So this is the same thing. Coke versus Pepsi, CTV bagels versus Subway sandwiches, competing goods. You raise the price of Subway, more people go to CTV. But peanut butter and jelly, if the price goes up for peanut butter, the quantity of jelly will go down. Yeah, well,
how do you know the ratio between them? Like, how do you know that? Like, I understand that if the price of Subway goes up, then more people will go to CTV. But how do you know?
If you want a numerical number, you have to run the experiment.
Okay.
You just have to run the experiment. There's nothing. Econ doesn't tell you how people will react. Otherwise, we wouldn't have to teach you in econ. Because as babies, you just know. I'm supposed to do these things. No, it just empirically we have to go out and measure.
Okay.
The thing that you need to know is that the direction. In this case, with substitutes, Subway, the price of Subway goes up. The quantity of the other good goes up because substituting, the switching. In this case, complement isn't about switching, it's about they always go together. So if the price of something that always goes together goes up, then I'm going to buy less of the other good because I'm going to buy less of this good. So these things are just directional. So that's where I wrote these two numbers, greater than 0 and less than 0. Here the sign matters, so don't put an absolute value because the positive and negative just reflect the directions. Justin?
So what's the thing with peanut butter and jelly? So like, do peanut butter companies talk to like jelly companies, like regarding like their prices, like to make sure that one doesn't like mess up the other?
Let's use a more hotel example. Do airlines like destination? So the Philadelphia area has a convention center with hotels. They want to negotiate things with restaurants. They want to negotiate things with airlines, because they know that if the airline prices go up a lot, then their business is going to go down.
Right.
So there are where there's no cross price elasticity, there's no strategic real reason you need to talk to each other about pricing. But where there is, then you do need to talk to each other.
Okay, so they would talk to each other.
If they were allowed to. I think in that case they're allowed to. Antitrust reasons you're not allowed to. Which is week 10, you don't have to know the word antitrust. Stephanie?
So I'm just going to check about the formula again. So if we're using peanut butter, jelly, and almond butter as examples again, percent change Q quantity for demand would be, would you set that as one of the things that can be substituted, or one of the things that is the complement to the substitute? Like,
So I like to think the thing on the top is the main good.
all right, the thing on the top
The
is the
main good, and this is that other good.
Okay,
So if we're thinking about peanut butter as the main good, we're thinking about raising the price of jelly. But we could also think about jelly as the main good and raising the price of peanut butter.
all right, so is almond butter not a factor in this then? Do you not touch almond butter?
And if we did peanut butter, doing what I had on the board here, with peanut butter and almond butter, then peanut butter would be the main good,
Okay,
and I'd raise the price of almond butter.
all right.
See how.
So what goes on top is the main good, where you're trying to determine its relation to either the substitute or the complement.
Yes, yeah. So main good, other good, and the two goods are related as complements or substitutes based on the direction of it going up or going down when you run the what if price experiment.
Okay, I think I understand now. Thank you very much.
You're welcome. The last one is income elasticity. This is where you do a percent change in income and you look at the percent change in demanded. We've already seen this with shifts in demand. We ran the experiment where I think about, I have a demand curve, I have a single point, and grandma sends me a big check, and I think, do I want to eat more or less of Subway sandwiches, right? So many of you will be grandma check. She sends you a big check, you'll eat at Subway more often. So in that case, your income elasticity is greater than 0. We call it a normal good. Most goods are normal goods. If income elasticity is so high that it's greater than 1, meaning I double my income, I might triple my Subway, then I call it a superior good. And in fact, you can think if I double it and I buy way more than the increase, then I just really, really like that. There's something about, when my income goes up, that's something I want to buy. Superior good. Not having to do with quality. It actually is more of a mathematical relationship than a quality relationship. The quality story is more around this inferior good. Is there anyone here who hates Subway? Okay, some of you hate Subway. If grandma sends you a check and you were eating at Subway before because it was the closest, cheapest thing, now you, so I'm going to write Will and Brett. I hope that's okay. You raised your hands if you don't like Subway. If grandma sends them a check, they're going to eat Subway less, and it's going to shift the other way. Okay. So normal goods would shift to the right for demand. Demand shift normal. And inferior goods would demand shift left. Inferior with a price increase. And we have, if you did, with the income increase. If you did an income decrease, you would apply the same formula, just like when we had price elasticity. Once we know the price elasticity is 5, we can use it to estimate adjustments with positive forces and negative forces. We can do that the same thing here. So if Will and Brett, grandma sent them a bill for sleeping over all those times, then you might have to eat at Subway more often because you don't have any money. You know, you like Chipotle, you don't like Subway, but you have to eat more at Subway because you can't afford Chipotle. Okay? Will?
What would be on there would be the superior good? Like what would be the, I see the normal and the...
So here I'm using a demand curve for Subway.
Okay.
And the normal good is, Subway is a normal good for all the people who, if getting a check, they would get more.
Yeah.
So we generally would you're asking a question between individual and market demand, I think.
Well,
So your individually demand-wise, Subway is an inferior good for the two of you. It's a normal good for everyone else. If I add up all the demand curves and had grandma send a check to all of you, then what would be the overall result? That would be, I think that's what your
And that's when you can ask whether or not it's superior
or normal good for the market overall.
Okay.
Yeah. That's a small nuance. If you're shaky, focus on getting your shaky solid, then getting additional shaky. Okay. Price elasticity of supply is percent change in price. Here we're thinking for sellers, and on top we have percent change in quantity supplied. In this case, we don't need the absolute value because we have them going the same direction, right? So for a supply curve, when the price goes up, the quantity also goes up. So P up, Q up. Supply. Therefore, we don't have to have absolute values. Same nomenclature of inelastic, elastic, perfectly elastic, perfectly inelastic, perfectly elastic. Vertical still is inelastic. So the concept check I usually ask people, describe the elasticity of supply for the curve shown. This was actually in a previous concept check. This was around airlines with 180 seats. What's your willingness to pay up to that? Or willingness to accept for the airline. So it depends on where you are. So in this case, I would say the airline is inelastic for prices between 0 and 149. Right at 150, they're perfectly elastic. A really small shift will get them to change a lot. And then beyond $150, any price change is going to be perfectly inelastic. So again, an example, it depends where you are on a demand or supply curve, what the elasticity is. It's probably not going to be like this in real life. It's probably going to slope a little bit and kind of be something like that, depending on the costs involved to service each person. So in that case, you would just take 2 points. Let me just not use my mental chalkboard, but use a physical chalkboard. If I did this and said, what is the elasticity of supply at that point? You're going to say, oh no, I haven't seen this before in class. And then you're going to say, I'm going to calm down, think about my steps. I'm going to say, it's just force and adjustment. I apply a small force. I apply a small price. I look at the quantity. And I take this price and quantity. I then do the percent changes for them. And then I just take the ratio of the percent changes. And then you find it's probably going to be a multiple choice question if I do it. And you just find the nearest number to the number you calculated. So other elasticity signs matter here, especially for cross-price elasticity and inelasticity. And always adjustment over force. May the force be with you on the. Okay. So in consumer choice, I'm going to try to get through a good chunk of this, but I am almost certain I'm not going to get through a lot of it. I'm going to figure out what I want to do as I go along, because there's two things. I could either go through it quickly. Okay, I've decided right now your homework will be due on Friday, so that you will have time to come to class on Thursday and get some additional knowledge. I think what I'm going to do is try to run through this quickly once, and then you can look through the notes, and I'll do it. I'll just fill in any questions on Thursday. You?
Friday at 10 a.m. or can you do it?
It'd be Friday at 10 a.m. Yeah. So you could also do it after class and turn it in. If there's some real big reason why you can't do it, I think I wrote in the people who read my syllabus. If you really have a hard time, you can scan it and email it in to Erica, but she does not like that. So if there's some impediment, like you broke your knee and you can't walk, then that's good. Elsa?
Will the bin be out like the day before? Like if you wanted to turn it in Thursday, you could use those classes
Yeah, you can turn it in the day before, but the office is closed because we don't want people taking the exams. So you can turn it in the day before up to 4:30. But after 4:30, you have to wait till the next morning. Okay. There's associated reading with this. The chapters in the book are quite good at this. So read OpenStack, read Arnold on this. And I'm going to put that up while I pass something out. This is just the econ humor around Valentine's Day. I know we can get it. But, take one, pass it around, please. So may you find inelastic love.
Thank you.
So what I'm going to do with this in-class quiz, rather than make you do it right now because we haven't gone through it, I'm going to pass it out to you, and I want you to spend, I'm going to do a little bit of lecture and then pause for a minute and let you look through it. Circle all the things that don't make sense, and as we go through the lecture, you'll have the opportunity to fill in the things that do make sense. Because I want to model to you this idea when you come in, if things are shaky, then they become solid. As you acknowledge they're shaky, and then they become solid. Okay? Leah, did you have a... Two? Okay, Max, can you make sure two go that way? Okay. So, I'm going to ask you to resist the urge to look at it for 5 minutes, and then I will promise to give you a couple minutes in 5 minutes. So consumer choice, we model consumers making decisions maximizing their utility subject to budget constraints. We've already had this idea of maximizing their utility when we had Chipotle and CTV bagels, and we were thinking they want to buy from one of these, where are they going to get the most consumer surplus? So similar ideas are operating here, but here we're using a framework that is a little different. So we're using maximizing utility and budget constraints. A big part of this is just vocab, and so I'm going to get into this vocab. Before I start talking, the context for consumer choice, we've learned about demand and supply, and we've been talking about it, but this lecture is only about demand and consumer choice. So erase everything in your mind about supply for the remaining of this lecture. Well, afterwards, we'll start looking at firms, but this is the last lecture, excuse me, this is the last lecture where we look directly at demand. As Will has asked through a series of very insightful questions, how do we know what the demand is going to be? The answer is always, it comes not from some objective analysis, but from asking people, running experiments. If the price is this, how many do you want to buy? There's no other way to do it. There are principles about how elastic or inelastic someone would be, depending on the time period or necessity versus luxury, but there are no hard and fast rules. Once we get to businesses, we will have really nice hard and fast rules. It will be less fuzzy. But today we're doing demand in this consumer optimization, consumer maximization. So this is only about demand, no supply, no market equilibrium. So if you say supply, I will remind you that in this section we're not talking about supply, we're just talking about the demand side. The model of this consumer choice is the origin of where the demand curve comes from. So the underlying part of this is this idea of utility. Utility is satisfaction or happiness, the thing that consumers are trying to maximize. If you look through the book, they talk a lot about utility. Utility is always a little messy because there isn't a utility meter I can point at your head and say, oh, your utility for this good is 7 or 10. But we can still talk about utility in the following framework. So utility is related to satisfaction, happiness, and it's the thing consumers want the most of. So terms related to utility are total utility, the total satisfaction of a bundle of goods. So maybe my satisfaction starts at 0, and then I eat one French fry, and it goes up to 10 in utility. And then I eat that second French fry, and it goes up to 15. And I eat that third French fry, and it goes up to 16. So total utility would be for 3 fries, might be 16. Okay, 16, the units for utility would just be utils. It's not necessarily dollars. We generally say the word utils. And sometimes we don't even write the units because it's just some arbitrary number. So total utility is the utility of every single fry, and then if I also have a soda, if I have 3 fries plus 1 soda, okay, then maybe it goes to 20. It doesn't have to be smaller because it's 1 soda. Soda is different from fries, so it can jump like that. So marginal utility has to do with the additional. The marginal has to do with these 1 extra fry. So if this is 1 fry, 2 fries, 3 fries, the marginal is the differences of 3 fries minus 2 fries. Diminishing marginal utility, just reminding you, we've already seen a lot of these ideas. The marginal utility is the additional satisfaction. Diminishing means goes down. So that first fry is really good. That second fry is a little bit better. And it raises my total utility, but the step is smaller. So it's like going up a roller coaster or a hill very slowly. At first it's steep, and then it gets shallower and shallower and shallower. Caleb?
Does util have a definition, or is it just a number? Is there some?
Util is just a number.
Okay.
Util, if you study this more, util comes from choices of things. Did you have a question, Sonia? Yeah, well,
Can utility go down? Like if you're on your,
Yes.
30th fry, you start coming
yeah,
down?
utility can go down, but generally we say people aren't forced to do things, so they can always say, I'm not going to eat that fry. So given that constraint, that free disposal is the term they use in econ. If you have free disposal, utility will never go down because you can always say, I don't want additional. So a numerical example, if this helps, my marginal utility of coffee at 2 coffees and 1 bagel is the utility at 3 coffees and 1 bagel minus the utility of 2 coffees, 1 bagel. Copying this down is not as important as thinking, if I'm figuring out coffee, I want to think 1 additional coffee, so I copy where I start from, I add an additional coffee, and I think how much my utility or satisfaction and happiness has changed. Okay? Also, marginal utility of coffee at 3 coffees would then be 4 coffees minus the starting point of 3 coffees. So marginal utility depends on what else you're consuming. So my marginal utility for burger at 0 sodas and 1 burger is going to be different than my marginal utility for burger at 0 sodas and 5 burgers. In this case, I would expect this to be lower because of diminishing marginal utility. Right? Marginal utility is going to be smaller for that going from 5 to 6. The change in utility is going to be smaller going from 5 to 6 than from 1 to 2. And that's diminishing marginal utility. So those are the pictures I showed you before. Yeah, well.
So do you measure marginal utility at a certain price, or is it from a certain price to another? Like, is it at 5? Does that mean from 5 to 6, or is it just prices around it?
In this class,
Yeah.
always do the starting point plus 1 unit. Okay. So one thing I'm going to pick on you, Will. Can I be tough so you learn more?
Yeah.
So you said, is it at a certain price? You meant certain quantity.
Yeah.
So I'm going to say this. The prices are not involved in the marginal utility. Utility is completely separate from prices. Completely separate from prices. Like, Will, I paid you to say that. So we have a new graph. So I need you to pay attention and not use your autopilot with every graph should have the same axes. Bundles are sets of goods. They're just putting number of Reese's on one axis and number of Hershey's on the other axis. This is kind of like what we use in the desert island models, right? Where we had fish and coconuts. We're just plotting those 2 things. So when we're talking about bundles, we're just saying this is a bundle. This is me thinking about having 5 Reese's and 5 Hershey Kisses. And this is 5 Reese's and 10 Hershey Kisses. So these are the different bundles. I just need to define bundle before I talk about difference curves. So each bundle is associated with a level of happiness or utility. So every single one of these bundles has a utility number associated with it. Okay? Indifference curves are sets of bundles that give the consumer the same utility. 1 curve per level of utility. Okay? So the key thing about indifference curves is always the same utility for that consumer. We're just connecting different bundles. think I'm going to give you another chance to copy this in 2 slides. So I'm going to ask you to pause and wait for a sec. Okay. Utility is a function of bundles. So how we would build an indifference curve, because this graphical will give you more intuition. So I pick a bundle and then I ask them to give a numerical score based on how much she likes it. So maybe 2 Hershey's and I think that's 10 or 11 Reese's. That would be 7. Okay? And then I pick other points and ask them how much do you like them. So if I ask for fewer Reese's but the same amount of Hershey's, she's probably going to like that less, unless she's allergic to chocolate. Like that. But if I think, well, okay, I took away some Reese's, how many Hershey's would I have to give you to get to the same level? She might say, I need 5. So these 2 points are in the same utility. Okay? Same utility, same utility. I can ask, what are all the things, if I give you side by side 2 options, you're like, I would be just as happy with both of them. Those are all these 7 points. Okay? And consequently, I could get 8 points, I could get 9 points, I could get 10 points, fill in more points like 4, etc. When I connect all of these points, right, when I ask and find all the bundles with the same utility and connect them, then I get indifference curves. So pick a point, ask for all the points with the same utility, repeat, and then you'll connect the lines of those with the same utility. So there's a bundle in here that's 3.5, and then 1, 2, 3, 4, 5, 6, 7, 7. That would be another bundle that we would say is the same utility. All points, even the ones in between that I don't have yellow dots on there, we would say is the same utility. And it's not because Professor Chong said it's the same utility. We actually took a person and asked them, what would you be indifferent between? Hence we get the indifference curve. So I'll just repeat to you in case you didn't get a chance to write it all. Now I'll just go back, because I want to be a man of my word. Okay? Indifference curves are sets of bundles that give the consumer the same utility. 1 curve per level of utility. Justin?
I don't understand how an entire curve is 1 level if it's like, if it goes to the entire graph. Like, what do you mean by level, like same utility?
Level of happiness, meaning they would be indifferent. So if I'm blanking on items. So eating at Max and eating at Terrace, right? Let's say you don't care about, they're the same to you. Okay? So if I said 5 times, eating at Max 5 times and Terrace once, or eating at Max 6 times and Terrace 0 times. And you have to believe that Max and Terrace are the same body. They're not. But just for the purposes of this, they are.
Right.
Then you would say, I don't care. They're different. Or if I think 5 times at this subway and 1 time at that other subway, or 6 times at one subway, you would say, I'm indifferent.
Okay.
So now, but you can do that with goods of Reese's and Hershey's. You can say, what this curve is saying is that you like variety, because even with the same amount of Reese's and Hershey's, so this might be 10 Reese's and 2 Hershey's, so 12 candies overall, you could have 5 and 5 of each, or you could have 10 and 2, and you'd have the same happiness. So here, it's not a one-to-one trade-off. Here, once I take away some Hershey's, you're going to say, you're going to need to give me extra Reese's to get me to be, get to the same level of happiness.
Right, I think that's what I was confused with, because I don't understand how like they're like different amounts, but they're the same utility. Like meaning like that one you can have 12 pieces of candy, but the one down there you can have 10.
So this person likes variety. So if I want, this is a good story. Okay, so suppose I have sushi and I have soup. Those are the 2 things I eat for lunch all the time. Okay, so 2 and 2. I like variety. I like to split them up. But then you ask me if, and then the other days I bring my lunch, and let's say, other days something happens. Let's ignore that thing. And I say, eating 2 sushi, 2 soup in a week, what would be you be indifferent towards? And I probably wouldn't say 4 soup. If I like variety, I would rather have 2 sushi, 2 soup than 4 soup.
Right.
So then you'd have to say maybe eating soup 6 times, 3, 4, 5, 6, is indifferent to this. So then I would say these two have the same utility. And I'd say, well, what if I cut your sushi down 1? Would you be willing to take 1 soup? Instead, I'd say, no, that would make me less happy. So then I would say you probably have to give me a little extra soup to get that. So connecting all those points gives me the same utility. Is there an indifference curve in between these two indifference curves? Yes, there is. There's an indifference curve through every single point. We just don't draw every single point. Yeah?
Is there a mathematical indifference, or is it one question?
I would generally give you a drawing of it, or I'd ask you some qualitative question about utility in indifference curve. No, I wouldn't say completely random because it comes from talking to someone, and there are a few rules that are going to be violated. So I can't have an indifference curve like this. This is not okay. An indifference curve like this. Okay? Puzzle on that, and everyone else will see the answer second. So I promised you that you could read through the quiz. So why don't you look through, and I will take DJ's question while we're looking through, and then I will keep going a little bit. Sorry, I couldn't hear them. Sometimes?
Sometimes, you don't even use the existing utility, so it's kind of like an arbitrary number.
I'm going to take this test with DJ, so you just read. Because I don't think this is
It's left or right?
This is just a list.
What are you?
You pick 2 things, right?
So I don't know how much we would pay
More like it here.
Huh?
for this
Yeah.
column. How much we would pay? Or would
You?
I have no idea what that
I
is.
don't know. If you're greedy, you'd pick the second
I think it's like
one.
a check.
If
Like
you're
which
not
one you
greedy,
choose.
you'd pick
Oh,
the
okay.
first one.
Oh, I'm not looking at the chart? Oh, they're right.
Oh, no. I think he's actually, he just wants to make it fun. So like, what's your favorite tropical location?
Oh, which
Oh,
one has
Because it says
more-
collection for a blank actor. I think
Right.
George Clooney was, but
I get
I don't
happier
know.
from vacations than I do the movies.
Zac
Huh?
Efron.
Hmm?
Zac Efron.
Exactly.
Just kidding, he's not with it.
Maybe I
Who is it? Did you actually ask him?
Yeah, right?
No, I didn't. I was really happy for Leo.
Yeah, he's really good. He should have won earlier though. Like I feel like he's in better movies, but this is the movie that he's gonna remember that he won the Oscar for.
Because it was mostly all actually acting and not just dialogue.
Yeah.
So like, more monologue and.
True. I wish he won for Wolf of Wall Street. That was so good.
I never saw it.
You never saw it? No, you have to see it.
Fucking fun.
Do you actually? Isn't it so good?
Like I didn't keep watching because I don't have
There's like
Oh, you have
no
to.
value.
Ah, I love
Like,
it.
like unit of
okay,
measure.
so which do you number one?
Like,
So it's starting from none of, from none of each item, which is more like the truth.
I love it. Marginally. Okay, so let's just think about the prize thing. So the marginal utility of the small one
Okay.
is going to be more, isn't it? Isn't it the first one?
Okay. Have you at least, even if you don't have the answers, have you at least circled things that are confusing to you? Or things I have not learned this yet, and I'm going to pay attention when I learn this so I can answer this question. Okay, yes, go ahead. For the 2 goods, it doesn't really matter. You can put Reese's and Hershey's. All right.
What about the,
Let's talk about page 1 right here.
what about number
So
2?
you can do Reese's and Hershey's. This is separate from this thing. This is separate from this.
what about
What
the
is
actual
left and
clock?
right?
Hmm?
Left or right for number 2?
Oh, the left, the small item,
Oh.
or the big item that you search. Okay, left and right.
What do you want on the blanks for the right side?
Where? This one?
The right, next to big item.
Oh, these are just for you to write down a location you like, or
Oh,
something you
okay.
like, or an actor you like. Just so you remember it. If you don't care about those things, do this one. Okay, Will?
What are the different points on the graph? Do they matter or no?
The 4 points are this, and this. The 4 circles that are.
Okay.
I'm talking about these 4 larger dots. So I'll put X's in them because
Yeah.
you can't see. Those 4 larger dots.
Is there like, so there's technically no unit of measure for margin?
There's technically no unit of measure, but we still talk about it, and there is a unit of measure, and it's more complicated and it's worth explaining, but if you want to know the real answer, I can do so individually. So you might have some confusion, you might have some solidness. You don't actually have, I haven't given you all the information that you could understand everything on here, but by the end of next lecture, I'll be able to get through that. So just so that you have some ability to get through your homework, I'm just going to give you the answers to some of these questions, and I'm probably going to give you something very similar to this on Thursday, just so that your brain is activated to do more things. So the marginal utility of a big item is probably bigger, so it's probably this one, right? Because the additional satisfaction I get from the trip is probably going to be a lot more than 1 movie ticket. And marginal utility always refers to 1 unit of that good. So it's not the same amount of money of that good, it's 1 unit of that good. So which one has more bang? Because later I'm going to use the phrase bang for the buck. It's the right ones. Because 1 ticket to 10 Laker games, for me, is going to be a lot more fun than 1 bagel. Okay? When I go to indifference curves, these are like topographical maps. These are like level sets. If you know topographical maps, great. If not, this is Ithaca, and this is a topographical map of Ithaca, right? This is slope. This is West Campus and the slope somewhere here, right? So it's lower elevation, higher elevation, even higher elevation. Moving to the right, it's higher elevation. Each of these lines is all of the elevations that are the same. So a hokey thing is, think of it as utility mountain. There's actually a space where there are axes that are Reese's and Hershey's, and we're plotting all of the things that are the same height. So we're plotting the same height, okay? We're plotting that same height, okay? Utility mountain. So which way is higher in the mountain? It's higher in the mountain up and to the right here, okay? So in this case, everything out here is going to be even happier. So if I draw another indifference curve, even happier utility, even higher utility, even higher utility. The question of the 4 dots, which is the highest utility? Well, this is 1 indifference curve. This is the higher indifference curve. There isn't a higher, this one has the highest dot. So this point, which I'm just going to label A is the highest utility of all of the ones that I've drawn. Not down here, not this one, not this one. Yeah, Duke?
So it's just which one is closest to that far corner, not like multiplying the numbers on the next line.
None of the numbers, but it's not always the one closer to this. Because I could draw a point here, B, okay? B is closer to that, but it's on a lower indifference curve.
So it's really just the y-axis.
Not just the y-axis, because I could be up here, C, and still be on a lower indifference curve.
So can you find utility by multiplying the x-axis on the y-axis?
Cannot find the utility by multiplying x and y-axis. You have to draw an indifference curve and see, am I on the happy side, taller side of the mountain, or on the lower side of the mountain? Everything down here is a lower mountain. Everything up here is higher. So when I tell you of these 4 points, which one is the highest utility, think utility mountain, and then that is the highest level set mountain. If you know topography, level set. If not, then it's, places sloping, right? Slope and sloping. Too much to do right now. Budget sets look like PPFs. So budget sets look like PPFs. And I want to just give you this idea of bang for the buck. Okay, we're not going to get to that through there. So I just want to read what's at the back of the page on the bottom. Let's use the idea of bang for the buck. Okay, use the items from the earlier question. Which one has more bang marginal utility? It's the things on the right. The expensive things had more bang, right? So why isn't it that we buy all the high bang things, high marginal utility things? Well, it's because we look at bang for the buck. So assume the items on the left are all $5. So all these things are $5. And the things on the right are $5,000. Now, I like the things more on the right, but I need to think for that amount of utility, what is the utility per dollar? So the key thing here is that this is utility per dollar. And that's the idea of bang for the buck. I'm already over time, so I'm going to completely stop there. You now have enough that if you look through the slides and use this idea of bang for the buck, you can do the whole homework. But I will go through it again on Thursday. Thank you very much for your time. I apologize for going over.